बेटा सिस्टम का ये जोर तेरे हाथ में ये सब गोल तू है भटका हुआ भूगोल देगी तुझको बस ये दुनिया खूब
Hi, welcome to Unacademy. Today I'm going to discuss questions on magnetic coupled circuits. Okay, for electrical engineers, magnetic coupled circuit is very important because completed electrical machines is itself is a magnetic coupled circuit. Okay, it's a coupled circuit. You can take a transformer or any motor or generator, anything. All these are coupled circuits. Okay, so with respect to network, I'll tell you what is a magnetic coupled circuits, how to deal with the magnetic coupled circuits. A few basic questions I'll take to find the inductance, coefficient of coupling, all these things I'll be discussing. Okay, so let's get to the first question. These are the questions you have to practice because I'll just give some number of questions. Okay, approximately 10 to 12 questions. You practice these questions. This is a basic one question, basic level questions. Okay, part one. In this part I'll discuss the basic level, and the next part I'll take up a little advanced level questions. Okay, let's get into that. Question number one: the equivalent inductance measured between terminal 1 and 2, these two are terminals of this circuit. What is the option? What is the answer? Option A, B, C, D. You can give it. What is the right one? First, tell me, these two inductors are conductively connected in series. They are connected in series. They are connected in series. Dot convention. Here, suppose current is entering here. I'll take some current direction. Current is entering here. Current is entering at dot, and here current is leaving at dot. Current is entering at dot and current is leaving at dot. So both fluxes are subtractive in nature. Both the fluxes are subtractive in nature. So I'll call it as negative coupling. This is a negative coupling. So series but negative coupling. Okay. For series and negative coupling, always self-inductance will be added like this. This, all are added, all are true. Negative coupling minus 2m. Negative coupling minus 2m. That's it. If this would have been a positive coupling, for a positive coupling what will happen? Plus you will get. For positive coupling, dot will be here. Or maybe you can say, if this dot is here, this dot will be here. This dot will not be there, dot will be here. This is a positive coupling. Then answer would have been C. Okay. For this question, what is given? Answer is D. L1 plus L2 minus 2m. Good. Let's go to the next one. Yeah. Answer this. Answer this. Take a pen and paper quickly, write it. There are different questions. You can see the questions. I'll show you the questions, okay? What kind of questions I'll be taking up. This we have different symbols, star, triangle, okay? All these different symbols are there. There is one more symbol missing. I'll take that. This one. I'll just take you to the questions. Okay, what are the questions I'll be discussing? This is this one, interesting one, and finally this. Okay, now we read this question. I think, yeah, we read this question. Answer this. What is the answer? What is the answer? Number. You tell the number. What is the answer value? You want any options? Okay, let me give the options. Option A is 15 Henry. Option B is 17 Henry. Option C is 12 Henry. Option D is 10 Henry. Yes? Answer is 12 Henry. Answer is 12 Henry. Okay, let's see how to solve it. How to solve these kind of questions. All three are connected in series. Careful with the process what I'm going. No, Vanshika. I'll tell you. First, all are connected in series. That's number one. That's number one. So what you'll do is you add all these series terms, all these self-inductances. This is what self-inductance and self-inductance. Process is important. Add all the self-inductances. L equivalent is equal to all self-inductances are add up 6 plus 4 plus 2. This is the first thing you should do. The second thing what you should do is, this is a mutual inductance between these two. Tell me, this mutual is a positive coupling or a negative coupling? Identify the coupling. This is a positive coupling. Put plus here. Why positive coupling? Because if current I apply current here, then current is entering at dot. Here also current is entering at dot. So positive coupling. What about this? This current is entering at dot. Here current is leaving at dot. Negative coupling. What about this? This mutual inductance, current is entering at dot, current is leaving at dot. This is also negative coupling. Put these minus here. Now it's easy. Plus, put plus, plus, plus 3, 2 into 3, 2 times of 3, okay, 2m, okay, 2m, because with respect to this also 2 times 3, that is 6. Here minus 2 times of 2, that is 4. Here minus 2 times of 1, that is 2. So these two are cancelled. 6, 6, 0. So you will left with only 6 plus 4 plus 2, that is 12 Henry. Here, rather than answer the process, the approach what I followed, you have to careful with that process. Okay, if you just stick to that process, you will not commit a mistake. It's simple. Series ones we added up, then we put plus and minus, then we simply multiplied with 2. That's it. We got it. Next one. Is it clear? Is it clear? Thumbs up. Thumbs up if it is clear. Share this video with your friends because they are the interesting questions. Actually in Henry I did silly mistakes multiplying 2 by 2. I wrote 6. Okay. You should be careful with this. You should be very careful with this. Okay. Silly mistakes, you should never commit mistakes. You should never commit silly mistakes. You should never commit silly mistakes because you know the concept. Just because of some, excitement or something, we'll commit a mistake. That's very wrong. Now the effective inductance of the circuit across the terminals AB for this. Now I think you should not do this mistake. Vanshika, you should not do this mistake. You try to fix it. You try to get the right answer now. Quick. I given the process, right? I don't think you should face a trouble now. Okay, let me do it. Here, all three are in series. So self-inductances are add up. 4 plus 5 plus 6. L12, that is L equivalent is equal to all self-inductances are add up. 4 plus 5 plus 6, it's done. Next type of coupling, look at this arrow. Is this positive coupling or negative coupling? This is a negative coupling, minus sign. Because here current is entering at dot, here current is leaving at dot, negative terminal, negative polarity. Between these two, this arrow, for this arrow, current is leaving at dot, here current is leaving at dot, here current is leaving at dot, for this also. So it is a positive coupling. Both are same, current leaving, here also current leaving at dot, positive coupling. Between these two, this is a bubble, this is a dot. Current is entering at dot, current is leaving at dot. So opposite, negative coupling. Now, minus 1 into 2, 2, plus 2 into 2, that is 4, minus 2 into 3, that is 6. Okay. So this is minus 2, minus 8, minus 4 you will get, minus 4 you will get, 11 you will get. 11 Henry. 11 Henry is answer C. Just simplify it. Okay. Done with that? Shall we go to the next? Yes. Let's get into the next one. Yeah. Solve this. Here we have a combination of series and parallel. We have a series as well as we have a parallel. I think you know for the parallel formula, just take that formula first. Write that formula for parallel additive. I'm just writing the formula for parallel additive magnetic, that is additive magnetic flux or additive in nature. Then that's a positive coupling. Magnetic parallel with positive coupling. That's what it means. The formula is L1 L2 minus m square by, this is fixed. Either positive coupling or negative coupling, this is fixed. Okay, so this is fixed, the black one is fixed. For a positive coupling, you will get here L1 plus L2. Here you will get minus. For positive coupling, you will get minus here. Minus 2 into m. Here you will get minus. Okay. What if this is a negative coupling? For negative coupling, in place of m, positive coupling, negative, the only difference is in place of m, wherever you see m, replace with minus m. That's it. Replace m with minus m. So here m square minus m square is also m square. Leave it as it is. Here m with minus m, you will get here plus. This is a formula. Okay. Oops, I think here the negative coupling values I forgot to give it, right? I'll give it. That's my fault. I forgot to give the negative coupling values. Coupling between these two, this is how much? 1 Henry. This is 1 Henry. Coupling between these two, this mutual is 2 Henry. Mutual I'm talking about, 2 Henry. Okay. Now, let's answer. Would you mind if I redraw it? Careful guys. Would you mind if I redraw this as this way? For the sake of clarity, I am redrawing it like this. No problem. Here we have 2 Henry. This 2 Henry, I am taking, just stop. Both are series 2 Henry. This is 3 Henry. This is 4 Henry. We have dot here, we have dot here, we have dot here, and we have dot here. And we know the magnetic coupling between these two is, this is how much? How much is these two? 1 Henry. The coupling between these two is 2 Henry. Okay. You're great. South Indian rocks. Yes, South Indian rocks. Indian rocks, man. Not South India or North India. India rocks. Engineer rocks. Double rocks. Electrical engineer, triple rocks. Anyways. This one. Now these two are in series. Now I can do this series operation, right? Just now we had done it. How to do a series? First add these two. 2 plus 2. Positive coupling or negative coupling. Here positive coupling or negative coupling. This is positive coupling plus. Here current enters here. Here current leaves here. So negative coupling. This is negative. Put this. Identify this type of coupling. Now, so these two I am talking about, these two. 2 plus 2. Then plus 2 into 1, that is 2. So resultant of these two is 6 Henry. Resultant of these two is 6 Henry. These two is 6 Henry. Now this is a negative coupling. So use negative coupling formula, use this formula with plus sign. Okay, simply substitute the values. Let me put it. L1 value is 3 into L2 value is 4 minus m square. M square is 2 minus 2 square or 2 square, it's all same. Minus simply 2 we should take because polarity also I have given already. Okay. So what I'll give? I'll use m square, that is minus 2 square. Let's put that. That's better, I think. Minus 2 square or 2 square, 4. That's 4 by L1 plus L2. L1 value is 3 plus 4 minus 2m. I'm taking minus 2m. That's for positive coupling. Minus 2 means for positive coupling, but m value is minus 2. M value is minus 2. Why minus 2? Because of the negative coupling. That's what, if you take it out, you will get plus here. That's it. 2 into 2, that is 4. Okay. So 12, I think 12 minus 4 is 8 by 17. Oops, what 17? 7 plus 14, 11. 11. So resultant of this is 8 by 11. Resultant of this is 6 Henry. 6 and 8 by 11 in series. So 6 plus 8 by 11 is answer. 11 is 66. 66 plus 74 by 11 Henry. Sorry. Resultant is 74 by 11 Henry. That's the answer. Okay. Let's go to the next question quickly. Here this is star. Here it's missing. This is star here. This is star. This is star. This is dot. This is dot. This is triangle. This is triangle. Careful with this. Answer this. If you answer this, I think you're done with these questions. These inductance calculation questions for a mutually coupled circuit. Okay. Okay, let me solve it. Here we have different symbols. Okay, so what is the matter after all? You will check all three are in series first. So all series self-inductance are add up. L equivalent is equal to 6 plus 5 plus 1. Now we talk about a mutual inductance. Look at the star. Star is here. Current is entering at star. Current is entering at star. This is a positive coupling. Triangle. Current is leaving a triangle. Current is leaving a triangle. So triangle is also positive coupling. Here dot and dot. Current is entering a dot. Current is leaving a dot. It's a negative coupling. This is minus. So plus, I'm talking about this, plus 2 into 1, that is 2. This is also plus 2 into 2, that is 4. Minus 2 into 3, that is 6. Okay. So solve it. You will get the answer. How much? Simplification? I think you can do that simplification at least. Answer is 15 Henry. 6, 5, 11, 12, 14. 6 is cancelled. Oh, it's not 15, it's 12, I think, right? 6, 5, 1. 6, 5 plus, this is 6. It's gone, so it's 12 Henry. Okay. Have we done some mistake or something? 6, 5, yeah, fine, good. This answer, 12 Henry's answer, okay. Next one. Any doubt so far? Any doubt so far? Next one. Take this. Interesting. Solve it. All are interesting. What want to? All are interesting. Solve it. Solve it. Simple things. If you know the basics, you can quickly answer it. When two coupled coils of equal self-inductances are connected in series in one way, the net inductance is 12 millihenry, and where they are connected in other way, net inductance is 4 millihenry. The maximum value of net inductance when they are connected in parallel in a suitable way. Interesting. First, what is given? Till this is one thing. Till this is one thing. You should understand this statement first. Okay. Try to understand this statement first. Then go to the second part of the statement. This is the first part of the statement. This part says two coils are connected in series. Okay. In one way means two possible connections are there. L1 plus L2 plus 2M. Other connection is L1 plus L2 minus 2M. So obviously additive for series connection, when they are in series, additive polarity will give maximum. So this value will be, maximum value is 12 millihenry. In case of a parallel also, additive polarity will give maximum inductance. So this is 12 millihenry. Here it is 4 millihenry. This is given to you. Okay, this is given to you. Now, here two coupled coils of equal self-inductance. So I can say L1 is equal to L2 is equal to L. Okay, see this one will be 2L plus 2M, 2L minus 2M is equal to this. So L plus M is equal to 6. L plus M is equal to 6 millihenry, I mean. L minus M is 2 millihenry. Okay, if you solve these two equations, you will get L is equal to, just solve it, solve these two equations, you will get L is equal to 4 millihenry and M is equal to 2 millihenry. With this statement, we got L value and M value, means L1 value, L2 value and M value, we got it. Okay, I'm erasing it. So which is equal to L1, which is equal to L2, because two equal self-inductances. Next one, what next we will be looking at? The second statement, second part of this question, the maximum value of net inductance when they are connected in parallel in a suitable way. I want a maximum value. If I do positive coupling, then only I will get a maximum value, that is series or parallel. So for parallel positive coupling, I will get L1 L2 minus M square by L1 plus L2 minus 2M. This is the formula. You know, now L1 is equal to L. This is L square minus M square. This will be 2L minus 2M. L value is known, that is 4 millihenry. Completely take out millis. No? Everything will get in milli. So I am just discarding milli. 4 square is 16. 16 minus, I think I can write here, L equivalent when connected in parallel. 4 square is 16. 16 milli square, of course, minus 2 square is 4 by 2L is 8 minus 4. Okay, so solving this, 12 by 4, you will get 3. Now we can bring that millihenry. Okay, answer is 3 millihenry. Are you following it? Question, if you understand properly, if you know the basic formula, you can easily answer it. Okay, try to follow the question carefully. Next one, try this. Answer. I'm waiting for the answer. You should be able to, you should answer these questions very quickly. Okay. Because these are conceptual questions, not, you don't have to use a formula or anything. You should know the concept to answer this. Yeah, okay. Enough time you have taken. Given two coupled inductors L1 and L2, their mutual inductance at induction M satisfies any one of these. What is this form? Which one? What is the relation between self-inductances and mutual inductance? K is equal to M by root L1 L2. What is the maximum value of K? The maximum value of K is 1. The range of K is 0 to 1. The maximum value of K is at max 1, ideal case 1. Okay. So if I take the maximum case as 1, then you will get M is equal to root L1 L2. If it is less than 1, if K value is less than 1, definitely M value will be less than this part. So I can say M is less than or equal to root L1 L2. Okay, from this formula is very important. Km L1 L2. Okay, Km L1 L2. Or you can remember M is equal to K L1 L2 under root. Okay, answer is D. Done with it. Next question. Take this. Answer it. You can take it if you want. two coils have self-inductances and mutual inductances, the coefficient of coupling. Coefficient of coupling means K. K value is awesome, that's it. Same formula what you used before. K is equal to M by root L1 L2. This is the formula. Okay. So it is asked for K value. Simple direct method. Directly substitute the values here. You will get the answer. 0.015 by under root 0.01 into 0.15. 0.015. Sorry. 0.15. This is answer. Let me just quickly solve it. 0.015 divided by square root of 0.01 into 0.015. Oops, we're getting something more. How come? Oh, self-inductance is, I did wrong. Self-inductance is 0.09. What I done here? K value is, sorry, M value is this. This is M value, 0.05, that's fine. Self-inductance is, this is self-inductance, this is self-inductance, right? So 0.09, why you're not saying anything? 0.015 divided by root of, sorry, 0.015 divided by root of 0.09 into 0.01. 0.5 is answer. 0.5 is answer. Okay? If you solve it, you'll get 0.5. Direct method, you need to know the formula. And you need to know how to use the calculator. That's it. Next, shall we move to the next question? Thumbs up. Thumbs up. Taste the thunder. Moved already. I didn't get a thumbs up, but yet I moved it. Moved on. Because I know you'll be lazy to thumbs up. That's fine. Anyways, next one. Yes. The coupling between two magnetically coupled coils is said to be ideal. Coupling is ideal coupling or perfect coupling. A perfect coupling if coefficient of coupling is 1. K value, if K value is equal to 1, we'll say perfect coupling. If you're a couple, if you're having a girlfriend or a boyfriend, then when we'll say you have a perfect coupling? When the coefficient of coupling is 1. Okay, whatever I am saying, my girlfriend is understanding everything exactly what I am trying to say, the way I want to say. That's a perfect coupling. Do you think that will happen? God knows. Next one. The maximum value of mutual inductance of two inductively coupled coils. The maximum value of mutual inductance of two inductively coupled coils with self-inductances. These are the self-inductances. Then what is the maximum possible value of M? M will be maximum. When M will be maximum? I told you the previous questions. M is, maximum coupling means K is equal to 1. If K is equal to 1, maximum coupling will happen, maximum mutual inductance will come. So M value must be equal to square root of L1 into L2, because the range of M is less than or equal to this. I want a maximum value. This is a maximum value. Alright. So under root 49 milli into 81 milli under root. Let's solve it. Under root 49 into 81. We'll get 63 millihenry. Answer is B. Answer is B. I hope you're getting the points what I'm trying to say. Yes or no? Yes or no? I'm hoping yes. Next question. It's an application. It's an application. You need to take few concepts. You need to mix few concepts here to answer this question. You need to mix few concepts. Mix it. Resonance concept, you mix it. resonance concept. Take the resonance concept, things will be clear. What is resonance? Try to understand what is resonance. Try to understand what is resonance. Basics of resonance, of course, not too much of resonance. Yep. XL, series resonance. It is exclusively given series resonance. So think about series resonance only. Think about series resonance only. What is series resonance? Condition for series resonance. Directly come to the condition. What is the condition for series resonance? Yes, when XL is equal to XC. Okay, XL is equal to XC. So here we have in the circuit, for the resonance to happen, we know XL must be equal to XC. XC value, magnitudes, we'll talk about only magnitudes. So total XL must be equal to how much? 12 ohm. XL must be equal to 12 ohm. They are connected in series. Positive coupling or negative coupling? Positive coupling or negative coupling? Tell me. Current is entering here at dot, current is leaving at dot. Negative coupling. So we know the formula for negative coupling series connected L1 plus L2 plus, sorry, negative coupling, right? Minus 2M. These are L equivalent, but here all are given in terms of ohms, reactances. So if we multiply with omega all sides, omega here, omega here, omega here, omega here, then you will get XL equivalent for the coupled circuit is equal to XL1 plus XL2 minus 2XM, mutual reactance. Okay, this is also true. Simply replace L with XL. That's it. Now this value must be equal to how much? 12 ohm. Then only it will be under resonance. For this value to be 12 ohm, we know already XL, these two values. 8 plus 8, that is 16, minus 2XM is equal to 12 ohm. Okay. So what should be the value of XM now? XM is equal to, it's 4 by 2, that is 2 ohm. 4 by 2, that is 2 ohm. Now, we got what? We got here the value of, XM. But what is asked? Value of K. This is not the answer. This is the value of XM. We should focus on now what is the value of K. How do you find value of K? We know K relation. K is equal to M by root L1 L2. Same thing I can write. Same thing as XM by multiplying omega, both sides, numerator and denominator. Under root you take it, omega square. So XL1, XL2. Okay. So I know XM value is 2. XM value is 2 by under root 8 into 8, that is simply under root 8 into 8. So simply we get 8. 1 by 4. 1 by 4 is 0.25 is answer. 0.25 is the answer. I hope you're getting the points, right? Simple, straight, easy, provided you know the concepts. Okay. Shall we move on? Yes, next one. If you're facing any problem, you just ask me that question regarding anything on this topics what I'm discussing. Anything, any question. Any question you have, you ask me from this topic. Done with it? What is the answer? What is the answer? If you get answer as D, then you are correct. If you get anything else, you are wrong. Let's see what is the answer. What is the solution? How to solve it? Two 2 Henry inductance coils are connected in series and are also coupled magnetically. They are connected in series, coupled magnetically to each other. The coefficient of coupling is 0.1. K value is given. K value is given as 0.1. L1 is equal to L2 is equal to 2 Henry is given, the total inductance of the combination can be, total inductance of the combination can be, there are two possibilities of series connection. One is plus 2m, another one is minus 2m. Okay, either of these two can be the resultant value. Let's see, L1 L2 is 2 plus 2 is 4, plus or minus 2 into m value. How do you find m value? We know k is equal to m by root L1 L2. So m is equal to k into root L1 L2. K value is given as 0.1. Root L1 L2, you will get 2.2. So this is 0.2. This is 0.2. Mutual inductance is 0.2. So two possible options are 4.4 for a positive coupling or 3.6 Henry. Either of these two can be the possible answers. This is for positive coupling, this is for negative coupling. Look at the options. Only this is there. 3.6 is not there. So this is the answer. It is asking can be. It can be. Okay. Done with it. Quickly take it. Shall we go to the next? Okay. Something interesting and bigger. Time has come. If you solve it, if you can solve it, that's it. That's it. If you can solve it, that's it. You got complete idea about what I wish to say about it. What I wish to say about this topic: series inductance and resistance calculation, coupling concept, the basic. Okay. This is a checkpoint question. Take this question. You may solve it now, but later on, checkpoint questions are like, you should regularly practice these checkpoint questions. These I would like to call it as checkpoint questions. Okay. If you try to solve these checkpoint questions on regular basis, then your concepts will be recalled. Okay. Read properly. That's the first thing which all of we don't have. When you see such a long question, we'll feel like, no, what is this question? So why this question is so long? No, we'll skip it. No, question is long means answer is simple, because more information is given, it will be easy to get the required one. But provided you are smart, if you are smart. In the circuit shown in the figure, it is found that AC voltage VI and current are in phase. So this entire line, what is trying to say in this entire line? Tell me what is trying to say in this entire line. He is trying to say the circuit is under resonance. That's it. These three lines into one single word, circuit is under resonance. Then only voltage and current I, they will be in series. Alright. Then the coupling coefficient, we already know this. This is by. This is divided by. Okay. The coupling coefficient K is equal to M by root L1 L2. We know it already. You don't have to say it. Okay. Where? Oh, sorry. It's given as into. It's not a wrong one. It is given as, intentionally given as K is equal to M into root L1 by L1 into L2. You have to take this. It is given. You have to take it. Where M is mutual inductance between two coils. Here M is mutual inductance between two coils. As per our formula, we should get M by, but here it is given as into. Okay. The value of K and the dot polarity of P and Q are. Means what is the value of K? And where should be the dot? At P we should have dot, or at Q we should have dot? That's the question. At P we should have dot, or at Q we should have a dot. Okay. I think if you are preparing for GATE, I already done GATE virtual calculator, how to use virtual calculator. Okay. All the important operations, everything I had done on GATE virtual calculator. You can check that video link also in Unacademy only, very recently, I think yesterday or day before yesterday. You check that, you will get complete idea about GATE virtual calculator. Alright, next, where we are? Yeah. So all this question we already understood. At resonance, what is the value of K and where is the dot? Whether dot should be here or dot should be here. That's the question. This complete line. Okay. Now at resonance, we know let's find out XL equivalent. XL equivalent must be equal to 12 ohms, just like before. Okay, here 8 and here 8, both are 8. Both are 8. Okay, both are 8. So we have already calculated for both are 8. I think for different formula we done it. For this formula we have not done it. For this formula we'll do it. Anyways, XL equivalent is equal to 12. So though both are in series, this must be equal to 12. In that case, what should be the value of K? What should be the value of K, and where should be the dot? So we have two possible options. One is either you have positive coupling or you might be having a negative coupling. Okay. So for this, what we'll do? Total is how much, guys? Total is how much? 8 plus 8, 16. If this would have been a positive coupling, there will be some other term which is added up to this. This will never come down to 12. This will never come down to 12. So this must be a negative coupling only. That's the first conclusion. It must be a negative coupling only. So if I have a dot here, then it will be positive coupling. So dot cannot be here. Dot can be only at this point. This is a dot. So option A is wrong, option B is wrong. Either of these two is right, either C or D. Okay, now which one? Let's take negative coupling. So XL equivalent must be 12. 8 plus 8, that is 16. I am writing directly. L1 XL1 plus XL2 minus 2XM. Let me write the formula. I'll write it here, that's better, I think. 12 equal to XL1 plus XL2 minus 2XL. Okay, so this is 16. You will get XM is equal to 4. XM is equal to 2. XM is equal to 2 ohms. But it is asked for K value for this formula. Okay, careful with this. If this would have been divided by, if this would have been divided by, okay, if it is a mistake, by mistake, if you got it, this will be divided by. Okay, let me cross check. This should not be given. It should have been divided by thing. If it is divided by, then you will get D as option, because we already calculated for 8, 8 and 12. We already got K value earlier. Just in the previous case, I think. Yeah, here we got 0.25. Yeah, here we got 0.25. So, sorry. So this should have been, I'm thinking this should have been divided by only. Okay, because they cannot change the formula. How come? The formula will be different. Coefficient of coupling formula means m by root L1 L2 only. Okay, so the answer is, we know already done the value of K. K will be equal to 0.25. We already done it. Same analysis, sorry, on this 0.25. C is answer. 0.25, C is answer. Okay. Correction, check this correction, guys. M by root L1 L2. Done with it. Shall we move on to the next one? Yes. Two coupled coils with L1 is equal to L2 is equal to 0.6 have a coupling coefficient of 0.8. Then the turns ratio, it is also for turns ratio N1 by N2. Here, one point you should recall from the basics of magnetic circuit. From the basics of magnetic circuit, you should recall one point. What is that point? Inductance L formula. There are different formulas for L. There are different formulas for L inductance. I'll list out all the formulas. N phi by I. N phi means psi by I. Okay. Or you can say phi you replace with MMF by reluctance. Okay. Then if you simplify it, you will get N square by S. S is what? Reluctance. Or you can say, instead of reluctance, apply the formula of reluctance. L by mu A. Mu A will go up. Here we will have L. So these are the formulas. I think you are not able to see all these maybe. Okay. I think now it's clear. These are the formulas. Okay. Try to keep these formulas in your mind. Inductance. Okay. So from this you can clearly say L is proportional to N square. just from this or from this. Don't use this, because in phi also you will have n. You may say, sir, here according to this we'll have only L is proportional to n. What about phi? Inside the phi also we'll have another n, another number of turns. Okay, so completely this is a 1, because now these three are constants with respect to number of turns. Length and m and a, these for fixed values of these, provided these are fixed, then it is proportional to n square. This is a point. Now L1, L2 is equal to 0.6. L1, L2 is equal to 0.6. So I don't have to use the value of k. I don't have to use a value of k here. Okay. Simply I can say L1 by L2 is equal to N1 by N2. Am I right? Am I right? No. N1 by N2 whole square, because L is proportional to n square, right? So 0.6 by 0.6 is equal to N1 by N2 whole square. You'll get 1. N1 by N2 whole square is 1. So N1 by N2 is also equal to 1. N2 by N1 is also equal to 1. All are 1. All are 1. Okay? Try to be careful. If you know the basic fundamentals, fundamentals should be clear. If you are clear with the fundamentals, you can build the other blocks later on. Okay? The next one, probably the last one. Probably the last one. Check it. A real transformer, that's a practical transformer, has a primary self-inductance, L1 is something, secondary self-inductance, L2 is something. The mutual inductance between primary and secondary is something, 3 Henry. Now it is asked for primary and secondary leakage inductance. Primary and secondary leakage inductance. We all know there is no perfect insulator for a magnetic metal. Commonly, what are the available things? They will be magnetically a little conductive, not completely conductive. Air. If you have a magnet, if you have another magnet, there will be a flux flowing through the air. There will be a flux flowing through the air. Air is not a magnetic insulator. Wood is not a magnetic insulator. Okay, there are no such a perfect magnetic insulators, unlike an electrical insulator. So if I have a core like this, if I have the core like this and a coil like this, I'm just giving an example. Okay, I'm thinking flux should go this way, because this is a magnetic path. This is a magnetic path. This is a magnetic path, which is having better magnetic conductivity than air. A little better magnetic conductivity, little better, maybe 10 times better. Maybe 10 times better. Okay, so there is some magnetic flux comes this way also, because air is also conductive, so it will come this way also. That's what the leakage flux we'll call. So it is asked about the leakage flux. Ideal case, the ideal case, there should not be any leakage flux. Ideal case, there should not be any leakage flux. Okay, there is no ideal case. There will not be any ideal case, just for study purpose only. Now, keeping this, it is asked for what is the primary and secondary leakage fluxes. Keep this point in your mind and tell me what is the value of primary and secondary leakage fluxes in case of a transformer structure. Transformer, it is given as a transformer. Okay. Now, how do you do it? Here, primary leakage flux. Primary leakage flux, let me represent it with small L1. Small L1. Capital L1 into 1 minus K. If K is equal to 1, if K is equal to 1, 1 minus 1 is 0, leakage flux is 0, perfect coupling. Similarly, L2 is equal to, tell me now, L2 into 1 minus K. There will not be any secondary leakage flux if K is equal to 1. Now, what is the value of K? L1, L2 values are given. What is the value of L1? L1 is 9 into 1 minus L2 is 4 into 1 minus, what is the value of K? K value is not known. What do? We leave the question, or we'll find the K value. You have two options. You can leave the question, skip the question, or you find the K value. I can find the K value very easily. We know the simple formula. K is equal to m by root L1 L2. we hardly have 5 to 6 formulas in this topic, man, entire topic. Okay, 1, 2, 3, 4, 5. Five formulas, and including the 6th formula almost. Most repeatedly asked things. Okay, keep this 3 by square root of 9 into 4. Okay, 3 by 3 into 6, I think, into 4. You'll get total is 3 by 6, that is 0.5. So this is k value is 0.5, k value is 0.5. So 9 into 0.5 is 4.5. Directly I can say this answer, because L1 is L1, small L1, leakage, small leakage flux, primary leakage flux. Small L1 is for primary leakage flux, L2 is for secondary leakage flux. This is 4.5, this is 2, so answer is D. Have you faced any difficulty in this? How simple is these questions, right? So try to practice the same question, same set of questions you practice. These are the good enough questions. Okay, these are the good enough questions for most of the competitive exams. Okay, 90% these questions will basic questions. I mean, there will be little advanced questions also. I'll take up those questions in the second part. Okay, in the second part I'll take up those questions. That's it for now. Thank you all. You can visit other classes. There are other classes on Unacademy Plus or here or other platforms. You go through it. Definitely you will enjoy all the sessions. Okay, thank you. See you in the next session with different level of questions.